be sure you review the material. You have access to everything, all of the slides, example quizzes and so forth are all on Vision. In the past it was all paper, okay? This year it will be digital. You will do it on a computer, okay? However, it still follows the same format. So if you go on to Vision and look at past year's exam papers, exactly the same format, same difficulty, same style, and I'll show the examples today. It's what you'll expect in the digital version, okay? Because I think there's the last 3 years exam papers online. Yeah, that's 3 years, isn't it? And then you've also got the example quizzes on Vision, which you can work through and practice. There's also questions in the slides. So you just practice them and you'll be fine. Today, there's no more new material, so as of last week, that was it. So I don't talk about anything new. I don't introduce anything. You've got access to everything now. All today and tomorrow is about is revising, okay, showing example questions and preparing you. Then you'll have a few weeks, I think 3 weeks is it, to revise, and then you'll have your final exam. Hopefully all of you should get 100%. It should be a walk in the park. If you study the material regularly each day, there's no surprises. Now, I'm just going to go through some examples. So I'll start from the simple ones that you did at the start with Idris. Hopefully you can see these simple examples and say, okay, I'm a bit rusty, but with a bit of practice, I can remember it. So can you all remember how to convert between binary numbers and decimal? Hopefully you should be saying, yes, I know the concepts. Obviously I know what each digit means and how I can do that. Remember, in the exam you will not have a calculator. You have to do these on paper. Okay, so be sure you practice them. I think you're all comfortable with these now. Similarly, decimal places. In the practice exam, a lot of you made mistakes with these. Okay, a lot of you did okay, but there was still a few people who got the answer wrong. And again, it's simple practice. So it's just a matter of working out with the decimal places, multiplying it, shifting it along, and then working out. So if it is 4 bits, remember the answer can only be to 4 bits. Even though it's recursive or goes on and on and on when you calculate it, pick the last 4 binary numbers. And again, because it's a digital exam, usually there'll be multiple choice, so it shouldn't be too bad. At least you've got a chance of calculating it and comparing it. Also, if you're given a question like this, so if you ask the question, can this be a value which can be an address of Word and MIPS? The answer is yes or no. What do you think? Now remember, it says justify your answer. So if you had a choice, you'll get half your marks for yes or no, and you get the other half for saying why. Now obviously it's got to be a multiple of 4. So if you just said yes, and it's worth 2 marks, you'll only get 1 mark for saying yes. You get the additional mark for saying it's a multiple of 4. Okay? So be sure you look at the value for each question. It should say this question is worth 4 marks, and you should think to yourself, wow, 4 marks, there must be 4 things, or it must be very difficult. If you see another question and it's worth 1 mark, it should be just yes or no, true or false. Multiple choice, something very simple. Okay? Now, can you remember your assembly language? Can you remember the different instructions? The different registers? Yes? I encourage you to learn all the different ones. Okay? Just as a hint, they are important. Here's a simple example. So what's the RA register for? Any idea? Go on.
Return address for subprograms.
Yes. So when you call a subprogram, a function, it knows where to return to. Hopefully it's self-explanatory. You've got RA, return address. Okay? But remember, you've got a whole different ones. So don't just learn the RA one, don't just learn the 0. Make sure you're also familiar with things like which ones are for the operating system, which one are for the functions, what's the 0 as a constant. Okay? They're in the notes, you can look them up, you should be able to explain all of them. Remember this diagram? Shows on a few slides. So obviously you've got a minimalistic overview of a computer. You've got input, output, a few things. could you identify the different blocks? What do you think? How many of them? I'll give you a clue in the exam. In the exam, if it was in the exam, okay, you would have a choice of A, B, C, and you'd have to select where to put the A, B, C, D. Okay?
The sort of top cross would be CPU, ALU, control unit, and memory.
What about the left and the right?
Oh, right, I thought you mentioned it in circuits.
Yeah, so input output, yeah, that's what I mean. So you'll see this was showed in the slides. In the digital version, if this was there, basically these would be pulled out and put up here with A, B, C, D, and you'd have to put them in their appropriate place. It's not difficult. It was shown on 3 different slides, so hopefully you've seen it enough times now where it's burned into your memory. How about acronyms? So you did see a lot of acronyms for the buses, for obviously the memory management, the virtual machine, MAR. It should be something you come across very often as well. Any ideas? Just by looking at it, you should see someone and go, that's definitely not it. Go on.
Is it the memory address register?
There you go. Even if you type in Google, Google will come up with this answer and tell you that it's the memory address register. Okay? And you can read about it so you understand it. Okay? Most of these acronyms are very common. You see them all the time. That's why you should learn them as well. Okay, now remember we did return address. What about the register AT? Any ideas? Go on.
Reserved by the assembler.
Yes. So there you go. So it's reserved by the assembler. Might change unexpectedly. You don't use it. Okay, you can see it, but it's not for you. Okay, so the assembler will use it for any special operations or any special calculations. Okay. You will have to know assembly. So this is where the lab should have come in to help you. So practicing the exercises. Hopefully when you see a bit of assembly like this, it's not overwhelming. I mean, this one should be very straightforward, I think. What does this simple instruction do? Got a choice 1 to 4. What do you think? Is it difficult? Go on. Are you sure? Are you confident?
Yeah.
It's just where you go, and you think, because you've done so much assembly now, you should say, it's easy. Because if this was in Java, would you struggle? No, you would say, I know that is that minus that equals that. Okay? So it's just number 1, T0 equals T1 minus T2. Okay? Now, if you have to explain why pipelines have problems, okay, what is the problem? What is the reason there are difficulties? Okay. Now, I know you think, well, remember I talked about pipelines? Pipelines have advantages, but we introduce something which makes it suddenly more difficult. What's that additional thing? So if we didn't have any, conditional logic, everything was sequential, everything followed everything else, would that be brilliant? It would, wouldn't it? But what happens when we introduce conditional logic?
Basically, you get a stall before the next instruction can fetch.
But why is there a stall? Tell me, what's the reason it's a stall?
So if you have a statement like in X, then Y. If you haven't executed and read, so if it's in X yet, then it doesn't know what Y is.
Yeah. Well, as I said, it's like a split. There's a choice, a calculation, and there's 2 options. So we can't start loading the next data because it doesn't know which data to get. So because of this conditional logic, suddenly you will have stalls or bubbles where it's got to wait. And this waiting is known as bubbles, like bubbles when you've got pipes. So in pipes you can have blockages and things which you don't want. So it's basically to do with branch instructions. If you didn't have branch instructions, pipelines would be perfectly ideal. There'd be no problem. But once you introduce this additional logic, this additional conditional statements, it suddenly becomes more difficult, and this is where we get hazards and so forth. Okay, so caching. Why do we use the cache? The cache is there obviously to speed up access time, so we don't have to go to main memory. There's different types of cache. 2 main types of cache. as direct mapped cache and fully associative cache. If I said to you, could you explain the difference briefly in a statement, or tell me what one cache is and what the other one is? Give me an idea. So, what's the difference between them? Any idea? Or do you think they're the same? Or is someone saying, I've never heard of that before? Was that in the slides? Okay? It's basically the number of choices. So obviously in a direct mapped cache, there's only one choice of line, so it's got limited flexibility. It's obviously simpler, where a fully associative is more complicated, or again, it can have multiple lines. Okay? So it's just understanding sacrifices and trade-offs. Now you're going to have to come up with some of the details on paging. So obviously we talked about virtual memory, and obviously there's page tables. You have physical address and virtual address. You have to have some overhead for the actual mapping. Okay? So when you're mapping a physical address to a virtual page, there's some additional bits which get appended to the address. What are these additional bits? So it was mentioned in the slides, 3 additional pieces of information. I mean, in the digital example,